Hello everyone, welcome to the TheGeoecolologist. I am Dr. Krishnanand and you have been watching my videos on various topics of geography and research methodology. So in this session on oceanography, we are going to learn about one of the most sought after topics in oceanography, that is about the movement of ocean waters as in waves, tides and ocean currents. But before we go ahead, don't forget to subscribe to our channel and do share the videos with others as well. So now, when we have already learnt about the salinity, the temperature and the density distribution in the ocean water, now it's time to learn about movements of ocean water. And movements in ocean water happens in three ways. One is in the form of the waves, the second is in the form of tides, and third is in the form of ocean currents. So let's learn about these waves, tides and ocean currents in today's session. So if we want to understand these types of movements of ocean water, we must understand what are the factors which we have already discussed. The factors are the temperature, salinity and density differences that influence or that are the trigger point for these movements. But apart from this, there are other factors as well, like external forces of sun, moon and the winds. So let's understand these movements of waves, tides and ocean currents and the factors associated with these horizontal water movements and also the vertical water movements, that is in the form of tide. So there are basic questions that needs to be answered. First basic question is that which is caused by gravitational pull between the earth, sun and moon? So the answer is tide. So remember, tide is the vertical movement primarily, okay, because of this particular gravitational force that we are talking. Then comes the second question, which is a large stream of water flowing through the oceans. Now, like a stream of water, remember, stream of water flows on land, a river flows on land, right? So if there is similar kind of stream of water flow in the ocean, then that is called ocean current, right? And the third point is which is formed as an energy. And remember, the transfer of energy in ocean water happens through this movement because of the wind movement, right? So if wind movement is there and it transfers energy through ocean water, then that forms a wave, right? So these are the three things that are important to remember. Tide is because of gravitational pull, ocean current is because of the temperature differences and also the density differences, and apart from that, the wave is basically transference of energy through waters because of wind action. So these are the three major things that we need to study. Now let's elaborate one by one furthermore. So if you look into this image and if you have ever been to a seaside, you understand what a wave is, right? So waves are nothing but oscillatory movements. Now remember a little from the physics, from the optics, that if you understand this wavy nature, right, this is what it is, an oscillatory movement that result in rise and fall of water surface. So it's the same concept of wave, right? Waves are kind of horizontal movements of ocean water. That is important to understand, right? Many people think that because there is this crest and trough, it is not just horizontal but it is vertical. But remember, the propagation line is horizontal. That's why it is horizontal movement of ocean water. Now, apart from this, what is the main important point here in the waves? It is energy. So the actual energy that we say is not the water, but rather it is the wind that creates that energy through water medium, right? So the energy for the waves is provided by whom? By the winds. That is important. And already in the climatology lectures, we have talked about various types of winds from global to the local scale, right? So that is where waves are important and wind factor is associated with the wave formation. So in a wave, what happens? The movement of each water particle is in a circular manner. Now remember, this is what we say is that a circular movement is triggered by this wave action, and wave has two major parts. The raised part is called crest. Remember the Horst and Graben structure we used to study, or in the fold structure we also talked about this crest and trough structure, right? So it is the wavy structure that we have already learned in geomorphology as well. So this is the same wavy structure, right? This is crest and this is trough. So the raised is called crest and the down part, this part is called the trough structure, right? Now let's elaborate further more. So in order to understand the characteristics of the waves, we must understand all these points. So look here, it is wave, crest and trough, which we have already discussed. So this is the trough and this is the crest part in this image, if you can see. Then what we have is the wave height. Now remember, from this crest, this top part to this bottom line, right? This is the entire distance, right? So this is called wave height. A wave height is entire height from the crest to the bottom trough, right? That is important. Then something is called wave amplitude. Now remember, if we divide this crest and trough from center, and this is one half, the crest half, and this is the other half, that is the trough half. So one half is called one amplitude. That is important to remember. It is one half of the wave height. Then there is something called wave period. Remember, it is about the frequency. So two successive troughs and two successive crests. So that is where you have wave period. It is merely a time interval. That is important to remember, right? Then you have wavelength. So it is the distance between two crests or two trough. That what we already know is wavelength. Then what we have is wave speed. So it is the rate at which the wave moves through water. That is called wave speed. And you remember the unit is knots here. And wave frequency, it is the number of waves passing through a given point. So remember, if it is one given point and the number of waves that pass through this given point, this is called wave frequency. So remember all these important terminologies related to wave, that is wave crest and trough, wave height, wave amplitude, wave period, wave length, wave speed, and wave frequency. That are the basic idea behind the construction, or behind, if you say, anatomy of the waves, right? So these are important points to remember. Now the next important point is that what are tides? Now, when you look into tides, remember it is about periodical rise. Remember, the word again is periodical. It means at a given interval or at particular time period, right? So that's important. And what is it exactly? The fall of sea levels or the rise of sea levels, right? So rise and fall of sea levels, that is what we understand as tides, right? And we already know there is a gravity influence by sun and moon on the earth, right? So that is where it is created. Now remember, they are vertical movement of waters. Remember, wave, we said it was horizontal movement, but tides are what? These are vertical movement. Unlike waves, waves are the horizontal movement. So here is important point to note that water movements which are caused by meteorological effects like said above are called surges. Now remember, when there is a tidal action which is vertical, not horizontal, these are also termed as surge, because a surge is the upward movement, right? It is not like a regular tide. Because of certain meteorological factors as well, the movement of water surges. So during cyclone, we tend to use this word surge as well. So the surge along with the tide, when it combines, it is a greater force. That is what we see, right? So moon's gravitational pull to a great extent is the major cause of the occurrence of tides, and many people think that only moon is responsible. Now remember, this is a myth, and don't confuse yourself that only moon is responsible. Remember, sun is also responsible, not just the moon, but the moon's gravitational attraction is more effective. That is important point to remember, because sun is very far away, and remember the concept of gravity, the distance, right? So distance plays a pivotal role. Because moon is close to the earth, it has more influence on the earth, and that's why it attracts the water, and that's why these waters surge up. That is in the form of tides. So sun's gravitational pull, that is also the centrifugal force due to the rotation of the earth, and that is where it attracts and also leads to the tidal formation. But comparing the sun and moon pulls, moon is the greater force. That is important point to remember here. Now taking some examples from the world, the highest tides in the world occur in Bay of Fundy, that is in Canada. That is important point to remember as an example. And remember, when the tide is channeled between islands or into bays or estuaries, they are termed as tidal currents. Now remember, if there is an upsurge in tidal water and it channelizes between a mainland and an island, so it becomes like a stream of river. Or if it enters a bay area, then also it is similar to a tidal current. Or even if it enters a estuarine region where you have a freshwater zone and the seawater zone, if this tide enters this particular estuary zone, then also it is referred to as tidal currents. So that is the difference between ocean currents and tidal currents. Tidal currents are basically what? They are controlled by the topography, the physiography. That's where the islands, bays, and estuaries comes into the picture. So that is the basic difference between tidal currents and ocean currents. That is a point to remember here. Now, the regular interval between two high or two low tides is 12 hours and 25 minutes. Remember, we have 24-hour clock system, and 24-hour, you have almost half time when two high or two low tides are frequency given. So there is a regular interval between this 12 hours and 25 minutes. That is important, but this is a generalization. Remember, there is also anomalies at certain places in the world where this time fluctuates, but this is an average value that you should remember. 12 hours and 25 minutes, that is the regular interval between too high or too low tides, right? Then there are certain more terminologies associated with the tide, that is something called flow tide and something called ebb tide. So what is this flow and what is this ebb? Now let's understand. A flow tide is also called a flood tide. Now remember the fluvial process, the river flood. So this is when it is a rising tide or incoming tide. It means it is coming on the land and it is creating a flood on the land. That is called flow tide, right? So it is thus the time period between a low tide and a high tide, that is the rising time. So from one low, it is rising to one high. That is when it floods the inside, right? And then what is ebb tide? Remember, ebb is what? It is receding, it is going back. So receding or outgoing tide is called ebb tide, and it is the period between high tide and low tide. So remember, from high, now it is going to the low. So that is when it is falling down, it is receding back. So ebb is just opposite of the flow. So if you can remember flood with flow, so flooding is on the land, and when it is outgoing, it is leaving the land, it is receding, it means it is the ebb tide. That is the difference. Now looking into the types of tides. So first one is the tides based on frequency. What are the names? Semi-diurnal tide, diurnal tide, and mixed tide. So what is this diurnal? Remember, in 24-hour clock system, when we say diurnal, the di means 2. So it means it is twice. So diurnal are one high and one low. So what is semi-diurnal? It means they are almost on half stage. It means they are the most common tidal pattern, that is 2 high and 2 low tides. So the frequency of high is 2 and frequency of low is also 2. That is semi-diurnal. So almost half of a diurnal. But in one diurnal tide, we have one high tide and only one low tide. That is the difference between diurnal and semi-diurnal tide. But as I told you that there are many anomalies and different mixture also happens of certain anomalies in the world at certain places. So mixed tide is also one type, that is on the frequency of occurrences which are not clearly defined or which are mixed in nature. Sometimes it is diurnal, sometimes it is semi-diurnal, right? So tides have variations in heights known as mixed tides, and they are generally occurring along west coast of Northern America, where you can see this mixed tide. So remember, western coast of North America and in the Pacific, in the Alaskan region, you can find such areas where you have this mixed tidal situation. The next important is the tides based on the sun, moon and the earth's position, which is most famous. So first one, that is spring tide. The word itself is spring, right? So what is the spring? When the sun, moon and the earth are in straight line, the height of the tide will be higher than normal. So when it is higher than normal, it means the gravitational factor of the sun and moon both are acting because it is in a line. But it will depend upon what kind of situation is the line in. It means if it is a full moon situation, it means moon is here, earth is in the center and sun is on the opposite side. So what will happen? There will be a spring tide. So gravitational pull of this moon and sun both are going to impact and the tide is going to be higher than normal. That is called spring tide. And when it happens, remember, it occurs twice in a month during Poornima and Amavasya that we say in Hindu calendar. So it occurs twice in a month. So in 1 month, you have one full moon and one new moon. So in new moon, what happens? The sun and the moon are in a common line again, and then there is earth. So remember, now the gravitational factor of the moon and sun is combined. So remember, during new moon and the full moon, you have the great tides which are called spring tides because the combined impact is there, right? So if you want to understand that which is the highest tide, remember which is the situation here. The spring tide is highest during new moon. That is important to remember, right? So new moon is called Amavasya and full moon is called Poornima. These are the phase of highest tides on earth in the world. Now going to the next one, that is called Neap tide. Now remember, Neap tide is occurring when it is normally after 7 days of a spring tide. The sun and the moon becomes at right angle to each other with respect to earth. So if you look into this image, what is happening in the first quarter? Sun is here, moon is here and earth is here. Now if you see, gravitational force is now divided between moon and sun. It is at 90 degree almost, right? So what happens? The gravitational forces of the sun and moon tend to counteract. This word is keyword, counteracting. So it is pulling this way and it is pulling this way. So there is a counteraction happening here, right? And due to this counteraction, the tides are actually lower than normal because there is a division of energy, right? So tides during this period will be lower than normal, which are called Neap tides. That is important to remember. So spring tides, remember, these are the higher than normal tides, and Neap tides are lower than normal tides. And remember, they also occur twice in a month during the first quarter as well as the last quarter, right? So that is important to remember. But spring tide happens, remember, 2 times in a month, that is during full moon and new moon. So these are the points to remember in terms of the gravitational pull. That was the second part of the tides. Now there is something important to learn about the magnitude of the tides. That is basically about the power. So how much is the magnitude of tide? How powerful is the tide and when it is more powerful? So there are 4 positions. One is called perigee, the second is called apogee, then you have perihelion, and then is aphelion. So remember these 4 positions. 2 of them is for moon and 2 of them is for sun. As we know that sun and moon both have their attractions on earth, right? So what happens? During both the situation, closeness or being far away from the earth, there is differences in these tides. So let's understand what is a perigee and what is an apogee. So this is basically for the moon. If you see perigee and apogee positions, right? So perigee is, the word itself is peri. It is in perimeter. It is around. So when moon's orbit is closest, that is called perigee. Remember, perimeter is the closest part. So it is called perigee, and during this period, obviously that unusually high and low tide will occur, right? So high tide will occur where there is a perigee position closest to the earth, then the other side will have the low tide. But remember the apogee position, it's just opposite. So apogee is what? It is the farthest position from the earth, that is moon's orbit is the farthest. And their tidal ranges will be much lesser than, because the distance will increase, and that's why the attraction, the gravity part will be lesser. So this is about moon, right? Now if we talk about helion, remember perihelion word, it is heliocentric. So the word itself is related to the sun factor. So it is perihelion, means again the word is peri, it basically means that earth is in the perimeter of the sun, right? It is closest to the sun, and that is about on 3rd January. So this is the time when earth is closest to the sun, and that is when unusually high and low tides occur during this time in the world. And then the farthest position opposite of perihelion is aphelion, that is during July 4th, and that is the time when you have, that is the tidal ranges much less than average during this particular time period. So remember perigee and apogee positions of the moon and perihelion and aphelion positions of the sun. That is where you have to understand how magnitude, the power, the surge of the tides actually depend upon these distances from the earth, right? So that is an important point to remember. And you can also draw this diagram when you are writing your answer if you are discussing about the magnitude of the tides in respect to or with respect to the positions of moon and positions of sun. Now another phenomena that is related to the tides is something called tidal bore. Now what is this tidal bore? Now remember, if this is a river and it is joining an ocean, so what happens? The river normally goes and flows into the ocean, but during a tide, remember what happens? The water from the ocean, due to upsurge, it starts pushing the river water in the opposite direction, and that is what we understand as the tidal bore. So when leading edge of the incoming tides forms a wave or waves on water that travels up a river or a narrow bay against the direction of river, actually tidal bore, the key point to remember is that the movement of the water is against the original direction of the river. So if you look into this image, this is what we say is the surge. It is moving opposite the normal flow of the river, and this is called tidal bore, and it is observed in all the Himalayan rivers like Ganga, Brahmaputra, Indus. And if you see their areas where they join the sea, you'll find this phenomena very frequently happening during the high tide especially. Now remember, intertidal zone is something that is related to the tides itself. So what is this intertidal zone? Also known as foreshore and seashore zones. So remember shoreline. Shoreline is a place where the water meets the land. So there are certain terminologies that we must understand. So remember, entire coastline has a shoreline which is divided into different areas. So one is called upland, the upper portion where you have a huge dune, right? Then what we have is the backshore. So backshore deposits where you have the berm crest and berm trough structures. If you have ever been to a sea beach, you'll understand what are these. These are small mounds that you see where the water comes during only high tides, right? So that is called backshore, and these are called backshore deposits as well, the berm crest and trough, right? Then after backshore, you have this particular zone which is on this line on the beach face, which is called foreshore. It means like your forehead, it is in the front, right? So it is the foreshore area. So first is upland, then you have backshore, then you have foreshore, right? And then you have near shore area, which is close to the land and the water area. That is important to remember that this is part of the near shore, where you have foreshore and you have inshore. So remember, the total shore is here foreshore, and inshore together is called near shore. And in near shore there are two divisions. One is foreshore, the other is inshore. And when you cross this inshore, you go offshore. Remember offshore deposits, offshore oil drilling. So this is away from the main inner line shore, right? So remember these terminologies that are important here. Many times multiple choice questions can be asked in different examinations, that what is backshore or what is the sequence. So you have upland, right, of the coast, then you have backshore, then foreshore, then inshore, and then offshore. That is important point to remember. And there is something called longshore, that is along this particular shoreline, right, which is an average line between a high tide and a low tide. So this is that shoreline. The average shoreline is determined by the average value between the high and low tide, right? So that is important point to remember, and the sequence to remember as we have discussed. Now coming to the last point in the tides, that is the effect of the tides. So in what ways the tides affect us? So tides act as a link between the port and the open sea. That is the most important point to remember. So from open sea, when a sea vessel or container comes or a ship comes to the port, remember the port is little landward and it is not in the open sea. So what happens? This connection is due to the tide, and if tide water is not there, it means these heavy ships cannot come to the port. So that is important, that tide creates an important linkage because it increases the volume of water. So some of the major ports of the world, such as London port on river Thames and Kolkata port on river Hugli, are located on the rivers away from the sea coast. That is important point to remember, and that's where tides act as a linking factor. The tidal current clears away the river sediments. That is also important because if there are too much of sediments, it means it will lead to the ship getting stuck in the water and also slows down the growth of delta as well. So that is another factor, that tidal current slows down the delta growth as well. So it increases the depth of water in which the ships can sail. That is about the safety of the ships also. It depends upon the tidal waters, right? So it also acts as a source for producing electricity in many countries and many areas of the world. So remember, these are the major effects of the tides, and also the phenomena that is related to this is the tidal bore, and that is also important for the richness of those estuaries that we have already learned. Now the last part of today's session is the ocean currents. So what are these ocean currents? Remember, these are the horizontal flow of mass of water in a fairly defined direction. The catch here is this definition of a direction. Remember, ocean currents are fairly defined in their direction, and they are just exactly like a river that flows on a land, but this river is not flowing on land, it is flowing in ocean. So it's like a water stream that flows in the ocean, right? So how does it happen? Remember, ocean currents are formed by the winds, the density differences, and remember this is linked to the temperature and salinity. We have learned already in the previous lectures in oceanography. So in ocean waters, due to the differences in temperature, salinity, and also sometimes the gravity and other events like earthquakes also influence it. But majorly the differences in density and temperature and salinity are the differentials that leads to the movement from one to the other place, and that's where the river starts to flow. This is where we say it is an ocean current, right? So the direction of the movement of ocean current is mainly influenced by the rotation of the earth, that is due to Coriolis force, and most ocean currents in northern hemisphere move clockwise manner, and remember, ocean currents in southern hemisphere move in anti-clockwise manner, and that is important point to remember. Now let's understand few more terms associated with the formation of ocean currents, that is gyre, drift, and stream. So what is the difference here? Any large system of rotating ocean current, particularly those which are involved in large wind movements, are called gyre. These gyres are exactly like whirling actions. Now if you look into this image, this is a whirl or kind of a circle that is created. This is called gyre, and they are caused by mainly Coriolis force, as we know. So when the ocean water moves forward under the influence of a prevailing wind, it means a fairly defined direction, remember, then it is called drift, as it is drifted away by the winds. That is important. So that is where the drift word is used in the ocean current. So term drift is also used to refer the speed of ocean current, in which it is measured in knots. Remember, 1 knot is 1.852 km per hour, and the best example is North Atlantic drift. That's why it is called North Atlantic drift. And remember, prevailing wind is the most important factor, and here it is westerlies in the North Atlantic drift that takes the entire ocean water in a particular direction. When a large mass of ocean water moves in a definite path, just like a large river on the continent, it is called a stream. Now remember, when large ocean movement water happens because of a particular differential in temperature and salinity and also density accordingly, then it is called a stream, because stream is basically a flow of water that we know on the land, right? So similarly, it is called stream movement. And best example, if you see, is the greater speed of the drifts, that is the Gulf Stream. So remember, drift is slower, but stream is faster. So that's where the name also signifies their nature. So if it is saying drift, remember drifting is slow movement, continental drift theory. But if it is stream, it is flowing, it is fast. So that is a greater speed. And the best example, if you see, is the Gulf Stream ocean current, right? So these are the words gyre, drift, stream, to remember when we are learning about the ocean currents. Now coming to the types of ocean currents. So on the basis of temperature, now remember, ocean currents travel from equator to the poles and from poles to the equator. So obviously it is very common that warm ocean currents would be coming from the equatorial region, that is from the tropics towards the pole, because you have more insolation in the tropics, right? So it is basically moving from equatorial regions towards the poles. That is the first point to remember. Then what they do is they bring warm waters to the colder regions of the world, and they are usually observed where? On the eastern coast of the continents. Now remember, the word here is not just eastern coast, but usually. The usual behavior or the majority of the ocean currents which are of warm nature are found where? On eastern coast of the continents. That is a generalization, but there are certain exceptions. Like for example, in northern hemisphere, they are also found on certain areas like western coast of continents in the higher latitudes, that is near Alaska and Norway. That is why Alaska and Norwegian currents are also warm currents, but they are not on the east coast. So these are the important exceptions that we also need to remember. And furthermore, the opposite of this warm is the cold ocean current. So cold ocean current is obviously coming from the polar regions and moving towards the equator, as we know, and they bring cold water to the warmer areas. And remember the latitudinal heat balance, we already talked about how ocean currents try to change the temperatures and distribute it over all the globe. That is important here, that they bring cold waters to the warm areas, and these currents are usually found where? Just opposite side, on the western coast of the continents. Those used to found on eastern coast usually, and there also was an exception. Here also there is an exception in northern hemisphere, that areas like Labrador, eastern Greenland, Oesio, all these areas are full of these cold ocean currents, but they are not found on the western coast. So these are the exceptions, like we have exceptions in the warm currents as well. Just remember the exceptions as well, because many times question does not come or cater to the mainstream ocean currents, but rather to the exceptions. Now there is another classification of these ocean currents, that is on the basis of surface current and deep water current. So remember, in surface currents, the constituent is about 10% of the waters in the ocean. And remember, it is up to the depth of 400 meter of an ocean, and this layer from the surface to this 400 meter, this is also called Ekman layer, and this is on the basis of the name of a scientist or the oceanographer, Ekman. So Ekman layer is the upper layer, that is largely the part of the littoral zone where you have shallow water zone, that is 10% of the all ocean water, and this transport, that is the layer of the ocean water which moves due to stress of blowing wind. Remember, it is because it is the surface part, so you have the wind factor also important here. This kind of transport due to the wind motion in the upper part of the ocean is called Ekman transport. So remember the Ekman layer, the upper layer, and also the Ekman transport. In details, if you want to learn Ekman transport, we'll be talking more about it in the lectures to come, but for now just understand that surface currents and the relation to Ekman layer and Ekman transport here. Then deep water currents. Now remember, the word itself is deep water, and this is 10%, so the remaining 90% is all deep water below 400 meters, right? And that is what is important in terms that they move around the ocean basin due to variations in density, and remember, density is linked to the temperature and salinity as well, and the gravity factor as well. So this is what you have to remember in this classification, like surface current and deep water currents, right? And that is where Ekman transport is linked to the wind factor. So if you see the prevailing wind direction, Ekman transport is towards the land, and if you see prevailing wind direction is opposite, then Ekman transport is away from the land, and that is where you have the changes near the land area on the surface. And remember the upwelling and downwelling of the ocean water. So upwelling basically means the water is going upward from the deep down. It means cold water is coming to the surface, hot water is being removed, and it is downwelling. It means that the water is going down, and that is where it is called downwelling situation, and that is where you have a change in pycnocline, that is density as well, right? So remember these points under ocean currents. Now the next important point in ocean currents we need to understand is the factors, right? So what are the factors that influence the origin as well as the nature? So two important points here, that origin and nature of ocean currents are determined by certain important factors. The first factor is the density differences. Now remember, we have already learnt about the density and its relationship with temperature and salinity in the previous lectures. If you have not watched the video, do go to the playlist and watch the video on this density, temperature and other distributions in the oceans. So as we know that density of seawater varies from place to place, we have already learnt about it. The density increases with increase in salinity and decreases with it, right? They are directly proportional. But when temperature increases, the density decreases, right? And when temperature decreases, density increases. This is the different relationship, and that is where you have changes in density triggering the differentials. So if there is place A and if there is place B, what will happen? The movement of ocean water will be determined by the differences in density, right? Because remember, if it is less dense, it is lighter, and if it is lighter, it is on the surface. Dense water is beneath the surface, so lighter will move quickly, right? And then there will be a circulation in a definite path. So this is where density differentials will create movement of ocean water in a particular direction, and then it will be called ocean currents, as we know. So what we understand is that such movements of water due to the differences in density are leading to a circulation that we already know as the thermohaline circulation, because it is related to the salinity, right? And salinity is called in terms of thermohaline circulation. And remember, in polar regions, due to lower temperature, the waters will be of high density. That is important, and this causes the water to sink to the bottom, and that's why what happens, less dense middle and lower latitudes, that is towards the equatorial region, that is where the cold ocean currents are created, and they rise, that is where upwelling is there in the warmer region. So coming to the warmer region, they again starts to rise and push. That's where you see that it is now upwelling. So colder water dip in polar region and upwell in the tropics. That is important to remember. Similarly, in equatorial region, the water goes on the surface and they dip near the poles, and that is where the circulation is created between tropics and poles if you observe on a larger scale, right? This is important to understand under downwelling and upwelling factor related to the differentials in density associated with also salinity difference. Then the second important factor is the Earth's rotation, and remember the Coriolis force is the most important factor here, and we already know that ocean water is affected by Coriolis force, and that is governed by Ferrel's law. Hence what happens? Ocean currents in northern hemisphere. Now remember, northern hemisphere is clockwise. It's not anti-clockwise. Remember, it is clockwise, that is towards the right direction, and ocean currents in southern hemisphere is moving in anti-clockwise, that is towards the left direction. So what happens? Remember, it is not like the wind system we talked. It is the different system. It is the water system, and it is because of the gradients, and Earth's rotation also has an influence. So larger. Remember, the usual impact is that in northern hemisphere the direction is clockwise, and in southern hemisphere the direction is anti-clockwise. For what? For these ocean currents. But remember, in Indian Ocean, due to the impact of Asian monsoon, as we know, the currents in northern hemisphere do not follow these patterns of movement all the time, only because of the freshwater addition, and then there is a salinity as well, and the temperature as well. All these changes happen, and there are certain anomalies which are found in Indian Ocean. They do not follow the pattern usually that is there in the larger part of northern and southern hemisphere. Then the third important factor is the wind factor. So we already know that the winds like trade winds and westerlies are the greater driving force and of ocean water. And remember, the direction of the wind changes and the direction of current also gets changed accordingly. So remember this particular diagram. This is very famous diagram of the ocean water circulation. So this is where you see that this particular line is the tropical position that is dividing the Earth in two parts, that is your equator, right, and Tropic of Cancer and Capricorn. So largely, if you observe from this zone, the movement of the warm ocean water is on the both sides, right, and then what you observe is the cold water is coming towards this right? So this is important point to remember, and you can practice this diagram as well, right? And there are certain changes that you observe in this, what we talked in the Indian Ocean, that does not follow the usual pattern, right? So that's important to remember here. Now, what needs to be practiced is, for examination, this particular map of the ocean currents that is based on Robinson projection. So what is this? It's a warm current and a cold current, all given by different names in the world. So you can learn it ocean wise, you can learn it also on the world map. So Pacific, Atlantic and Indian, and you can understand the names. And remember, here symbol is red for warm current and blue is the cold one, right? And apart from this, this is a codification in numbers. If you want to remember these red lines through warm currents, these are the numbers. About 22 list is given here, and cold currents, blue, remember, it is given here by numbers. So what you can do is you can pause this particular video here and you can keep marking and learning on your map. So map practice is one thing that is must with the ocean current, to remember so many names, because many times, especially in multiple choice questions, these are asked, but also for the larger portion in your writing part, when you're writing an answer, there also it will be useful, because you need to draw a diagram and explain which are the colder ocean current areas of the world, which are a few examples. So always quote few examples. At least you should remember 3 or 4 from each of them. So few cold ocean currents and also few warm ocean currents for the purpose of examination. So now, when we have learnt in details about the waves, the tides and the ocean currents and the various factors and nuances related to it, in the sessions to come, we'll be talking more about different topics of oceanography. So stay tuned, stay safe, keep watching.